build a simple script with you. Bash scripting in its core is a way for you to string a bunch of commands together. One example could be if you want to install multiple packages to your system. Instead of having multiple commands that you do, you can set up a bash script. Or if you install a package and then download a config file and then put that config file somewhere specifically, you can put that all in a script so that every time you run it, it handles it automatically for you with one command rather than needing to do all 3 steps, 4 steps, 5 steps, however many steps manually. The more you use it, the more you'll see where it's useful. One way you can look at it also is anything you would type into the terminal can be put into a bash script. So think of things that you do repetitively in the terminal, and then you can make bash scripts out of them to save yourself time and effort. It also contains certain programming logic like loops, variables, if statements, case statements, etc., error checking. So you can actually get a little creative with it and have it become a little more advanced. Like if it needs to download a file, but you already have the file, you can check for the file first, so you don't have to download it again. That's just one example. One important thing I don't see often mentioned, I actually didn't learn this for a while, is the concept of POSIX and being POSIX compliant. POSIX stands for Portable Operating System Interface. Effectively, they got together, a group of people got together and decided to make a standard way of having the scripting work. This means that if you're on one Linux system and you go to another Linux system, or even if you go to a different shell, like for instance, there's the bash shell and there's the ZSH shell, they are both POSIX compliant. This allows you to run your scripts in either one and they'll still work because they all agreed on how certain things would work. And with that, let's get into it. So we want to first start by creating a script. So I'm going to make a script called my learning script.sh. The first thing to know is you want to end it with .sh. That will inform the system when you go to run it that this is a script file, a bash file. So, nice blank text. The very first thing you want to include is this. In this line, you have a few different things. The hash sign and the exclamation point is called the shebang. This is a unique identifier that tells the system, hey, use whatever follows as the interpreter for the following statements. So you include /bin/bash to tell the system use bash in the bin directory for interpreting these commands. This is really useful for if you're running in a non-POSIX compliant shell. So for instance, fish is not POSIX compliant. So there are certain commands that work in bash that don't work in fish. Fish is still a great shell, lots of great reasons to use it. But when you run a script, you want to add this shebang bin bash to the beginning of your script so that you use bash and it keeps it consistent and you know it'll run no matter where you are. One of the first things you can add in here is using the hash, and then you can say this is a comment. When you have a commented line, this will not be executed. This is very useful for if you want to write information about a statement. So let's say you go, this is an echo statement. Oh, I'm supposed to have that. Now, this is very self-evident, so this is unnecessary comment. But if you have something more complex, you can add this in here to help you remember when you read it at another time what you were doing. However, the commented line doesn't actually impact the running of the script, so it won't change anything. Another thing it's useful for is if you're working on something and you have one thing there and it's not working, so you want to try something else. So you add this in, you can comment out a line and try the other one. So it's a way of also keeping something around without deleting it, but not having it impact the code. Be careful, you don't want your script to get too cluttered up with old code. It's very easy to fall into that, but it's just a very useful thing you can use for various things, for remembering or for just taking something out to test. As I've already added, the first thing is echo. So all echo does is, if you're familiar with other programming languages, you might be familiar with print. Echo is effectively print. It prints whatever you see here to the screen. So we'll save this and we will try and run the script. And it doesn't work. You want to know why? When you create a file, it does not automatically have the ability to execute and to be run. It is considered like a non-runnable text file. So in order to run your script, you need to actually grant the permissions to the file to run. So in order to do that, you do chmod plus X, then you put in the name of the file that you want to run. So in this case, it's the mylearning script. So you do chmod plus X mylearningscript.sh. Now, if you notice up here, this was gray, but this one was green. My test script is executable. This one is not. But now that I've changed that, they're both green. That means I can now run that script. So there you go. The echo is printed to the screen. To give just a very simple example of how this is just stringing commands together, you can do something like this. 1, 2. We have 3 statements sequentially, and it will run all 3 statements sequentially. Unless you introduce some other logic to change sequence, it will always run them in order. So that's your basics, just to echo out things. So you can echo out not only what you write here, but you can also echo out something like this. So in this case, it will echo today's date is, but then it will actually pull from the system date. So now you can echo out today's date is, and it gives you the full date time. If you, for some reason, need to echo out something like that, you can actually pull from various system environment variables. I'm not going to go too deep into that in this tutorial, but just know that those types of things are available and can be leveraged. Another example might be if you want to install a package. You would normally let's do yay-s, say NeoVim, right? I already have NeoVim installed, but now it'll ask me for my password here. I already have NeoVim installed, so in this case, it wouldn't really change anything. And if you notice, it's still asking me for prompts, so I still have to sit here and interact with it. However, if you come down here and you do -- no confirm, this will let you do the installation without needing to interact with it. So when you're scripting, it's important to be aware of whether you want your script to require your interactions like that or not. When you're installing a package, it will require your password for sudo privileges. So you can either run the script as sudo and then you won't be prompted for the password, or you can run it and it'll still ask you. Now it still has permissions granted and stuff, so it just went through. But this is one thing when you're writing the scripting to be very mindful of, is a lot of commands will have a way for you have it to automatically accept or something of that nature. I'm going to get rid of this. I want to start walking through some of the basics of the more programming end of thing. So you can set a variable such as x, good old classic x equals 2. So then if you echo, when you're accessing the value of a variable, if I just did echo x, it would print the letter x out. But if I do a $sign in front of it, it will print the value of x in this case, which is 2. And here's a good use of comments. I can comment out the date so it doesn't clutter up the output when I'm just focusing on this. So I'll save that and we'll run that. 2. That is the value of x. Now I'm going to make a few changes. What I'm going to do is I'm going to get rid of these lines. I'm going to set a variable named, So name equals David, and then it would be so you can use variables in the middle of strings and it will interpret it properly. So I set the variable name to David, and then I'm doing echo hello name. So then it should say hello David. Now that's great and all, but that will only ever put out David, so there really was no need for a variable. However, what you can do is use the read command. So read will prompt the user for an input. So now if we come out here and we run it, now it doesn't look like it did anything, but it's because it's waiting for an input. That's why I went to the next line. So then if I put in my name, it'll say that. And just to show you that it will change, I will put in not my name and it will change. So read allows you to make that variable more dynamic and change. And then if you have different users and you need to use different names, it lets you take the input. One other thing to point out is when you run this, if you don't enter anything, it'll just be a blank variable. So it'll show a blank. So it's just hello, and there's no name. So you can address this by adding if statement. An if statement is called a conditional, and what it does is checks to see if something is true or false. And if it's true, it'll do one thing. If it's false, it'll do another thing. So we'll step through it. So we go if true. Now, true in this case is a Boolean that has a value of true. Then what we're saying here is if it's true, then echo it's true, print that out. And you always have to end your if statements with an fi. Now, since it's true, it will always be true. So this will always run. But if we change it to false, that means it will always be false, so it will never run. So when we run it, oops, it doesn't run. I'm actually gonna comment these out so that I'm not running it every time. Now, I use true and false as an example, and what you would do is you would put in an evaluation statement of some kind. So you can say if this number is greater than this number, or if this variable is greater than this variable, or is this variable empty, or is this variable equal to something? So there's a host of different ways you can apply it. I'm just going over the fundamentals of the concept of the if statement here. I will, however, use one of those if statements. What I want to do here is when I take in the read for the name, I want to make sure that it's not blank. So what I can do is if we're doing 2 brackets dash z, the value of name, close. So what will happen here is if this name variable is empty, is blank, it will run this echo here. So let's change it to so if I put my name in, it'll run it. If I don't, it'll tell me it's empty. So how we can leverage this, so I'm going to start walking through it a little bit, is we're going to put in a check around these parameters so that we can If it's empty, we're going to do one thing, and if it's not empty, we're going to do another thing. If the name is empty, then we're going to say it's empty, but we'll be more specific. So we're going to say the name is empty, please try again and enter a valid value. One of the complementary things to an if statement is else. So you say if this, but then if that thing isn't true, then you go else something else. So we're going to do else. If name is empty, then we're going to tell them to try again. However, if name has a value, you can print the value. So we're going to start with name. And here's what we're going to do. We're also going to add we moved the echo into the else statement. So it will only print name if name is not empty. I know the nots and the negations can sometimes get a little confusing, but I will walk through this again. So if name is empty, do this, which is tell them to try again. The counter, so then else, so if it's not empty, you're doing the else in the statement, you will then do this statement. Please enter your name. Enter my name. Prints my name. If I don't enter the name, tells me it's empty and to enter a valid value. So this is a great way to do some very rudimentary input validation, and you can get more complex with it. And the syntax in Bash is not the most intuitive a lot of the times. Other languages, newer languages, are a lot more clear in what's going on. You know, look up the syntax you need for it when you get to the use case that you need. I'm not going to go too deep into it. This is how an if statement works, and then an else statement. So now we have taking in an input, having variables, and then if statements. These are some of your core fundamental things for your beginnings of your scripts, because this allows you to customize things. Like, let's say you wanted to do something in a particular directory, you can give that directory as a parameter, and then that parameter can then be used in your script. So you can give it different directories to do the same actions, but on different directories. Speaking of parameters, in Bash, there's actually two ways to get parameters into a script, at least two ways. One is what we did here, what we did read, where it prompts the user to give you an input. However, you can pass values in right in the command line. Let's say I run this, but instead of waiting for the prompt and then giving my name, I want to just type my name in right there and then run it. Now in this case, it won't work. But if we come down here, when you're accessing values from the command line like that, they come in literally as 1, 2, 3, 4. So $1 will be the first argument being passed. So what you can do in this case is, we'll just do this just to show an example, echo 1. So when I do this and I pass in my name, it'll print my name because it's accessing that value that was passed in as the $1. But now it's still asking for my name because I haven't adjusted any other logic. This is how and you can pass in multiple, my name, your name, etc. And you can just keep passing in space delineated parameters, and it will $1, $2, $3. So it's a great way to pass things in dynamically without needing to go through the whole prompt and reply. You can even start having your script call other scripts with parameters so that you can automate scripts running through scripts with parameters. It's a deep rabbit hole you can go down. So I'm going to mix this script up a little bit. Normally we start with please enter your name. I am going to actually borrow this is name blank, but I'm actually going to say is $1 blank. So what this is going to do is if there is no parameter passed in, it will then ask you for your name. But if you see down here, I'm using name, which means that if I do pass in an argument, name will actually end up being blank because it never got read. So what I can do is use the else clause and say else name equals $1. So walking through the logic, if 1 is blank, it will ask you to enter your name and will assign that value that you give it to the name variable. Else, so you're saying if it's not blank, you are assigning the value from the first argument to the name variable. This allows you to catch both situations. If we do, where we run it, it'll ask to enter your name. Then if we run it with the name, it'll skip past it and automatically just use it. If the user knows enough about the script to pass it in as an argument, great, they can just drop it in and move on. If not, you'll prompt them for that missing information. So now what we have is the first thing we check is there an argument? If the argument, and that's just the thing being passed in through the command line, is there an argument coming in? If there is not, prompt the user for a name. If there is, assign that value to name. Then what we're checking is if the user didn't provide an argument and didn't type in a name, it will see that name is still blank and tell the user to enter a valid value. And then if they entered a name, then it will finally get down to here where it will echo out their name. Now, one other thing to point out with echo statements is sometimes you'll want multiple lines. This line right here, let's say we say, oh, well, we want to have a new line. We want, please try again on the next line. So what you can do is you can add a \n, and that's a new line. \n stands for new line. However, if you just do this, it'll just print that out. So what you actually have to do is add a flag to echo, the E flag. I believe it means evaluate. So then when you run this, if you notice, please try again is now on the next line, but you don't actually see the \n because what it does is it interprets it as a formatting statement, if you will, instead of literal text to be printed out. So that can be very useful for if you have an echo statement with a bunch of stuff on it that you want to print out. Now, the next very important thing to know about is loops. So loops, depending on what you're doing with what you're using scripting for, you may or may not use them. If this is just a script to configure your system in a way, you may not need a loop. However, loops can be very useful. So I'm going to go over a very basic loop. So we're going to go for I in. When you start a for loop, what we're going to do is we're going to go for I in 1 through 4. What you're saying here is you want to loop 1, 2, 3, 4. So it's going to be 4 times. The dot dot is saying between these two numbers, loop this many times. And every loop, I will get assigned to whatever number that is. So on the first time a loop runs, I will be 1. The second time the loop runs, I will be 2. The third time the loop runs, I will be 3, etc., etc. This is great because when you're keeping track of loops, sometimes knowing which iteration of the loop you're in helps with other logic. We're not going to use that in this case. I decided to just print it out. When you say, okay, for I in this, then you say do. So use the do statement to tell it to do something. So in this case, do echo, this is, and then the value of I. You have to close your for statement, your for loop, with done. In the same way you closed your if with an fi, you close a for loop with done. So now we will run this. So it prints the name and then it goes into the for loop. And if you see, this is 1, this is 2, 3, 4. So it ran it 4 times because we told it to run 4 times. Let's say you want this for loop to be a little more dynamic. You don't want it to be just the 4 times all the time. One way you can do it is you can actually read in an input. So let's say read times. So like the number of times you want to run it. Then we can come down here to our for loop. Now, Bash syntax can get a little funky. So just roll with what I'm doing, because you can't just do times here. It won't interpret it properly. What you actually have to do is in front of it, put $, parentheses, eval, echo, this, and then you want to close the parentheses. I am not going to go into all of the syntax and why it's this way. Just accept this is how you do this for this, and if you're in loops and you need to do specific things, you can look up how to do it. This is what will work for this situation. Again, Bash syntax can get very... I know a lot of people who really hate Bash because of this. It's a great, amazing, powerful tool, but syntax can be a little cumbersome at times. So now what we're going to do is we're going to run it. I'll just pass my name so that it doesn't keep prompting me for my name. And now it's waiting for me to enter a number. So let's say we want to run it 6 times. And it runs it the 6 times. Just to make it a little nicer, we'll add in an echo statement. How many times do you want to run the loop? And we'll say 3 times this time. So now that we have a variety of tools in our toolbox, I want to go through this script and make it a little bit better. So one thing I want to add is if I come down here, now that we've added a loop past this statement, if the name is still empty, it'll actually keep running past it. And so it will go do the loop, but you still don't have the name, and let's say the name is critical to that loop. So what we can do is we can just simply add the exit term here. What exit will do is exit the script. So if it hits exit, it will stop the script completely and it will not run anything past it. It's useful for if you have an input that's absolutely required, and if it's somehow blank, it'll just exit the script. Now there's other ways to handle that. There's error handling, but that's beyond the scope of this video. Now, one other thing we can do, and this is more of just a side note, is you can do set-e. This will, if you hit an error at any point, exit the script on the error. This makes debugging your script a lot easier, as opposed to it'll hit an error but then just keep going if you don't have anything to handle it. This will actually just exit on error, and that will let you work through your script better. So when you're programming, because we're getting into the world of programming now, one of the things that's really useful to do is to program it first, little by little, getting the pieces to work. Sometimes, though, once you've programmed it, you start to realize, oh, I should have done this. Oh, I should have added that, or it could be better this way, or I missed something. So for instance, at first we just read the name, but we didn't have any handling for if it was empty or if the user didn't add something or anything like that. It's grown organically. The exit down here, we didn't have that at first, so then it would just keep going, but now we have the exit. So these are all tweaks that you make over time. So one last tweak I want to go through is to actually combine these logics. So we have an if statement and we have a loop and we want user input. So what we're going to do is we're going to make it where the script will keep asking the user for their name until they actually input their name rather than just exiting the program. As we start to modify our code, I'm going to do a few things. I'm going to add a comment in here saying, below this is the loop. We'll be more specific. the print loop. So I put that there just to separate out the code because we're not going to worry about that with what we're doing. And then below this is the old code. So now what we're going to do is we're going to kind of take these apart and kind of reassemble them. And we're also going to introduce a different kind of loop. We're going to do a while loop. So let me comment these out to start. So what we're going to do is, now if I was using Git, I would just git commit where we're at and not have this duplicate code here. However, I do not currently have this in Git, so I am going to just have copies of the code. So we're going to take this first chunk here. We're saying, okay, if this is empty, then please enter your name, else name equals 1. But instead of it just asking once, we're going to come in here and we're going to put in a while loop. So we're going to go while all right. So we're going to say while name is empty, do this. And a while loop, unlike for, so for will run for a set amount of times. While will just keep going until this statement evaluates to false. So we're going to indent these just for readability. So now what we're saying is if you didn't pass in an argument and name is empty, do this. And it says, please enter your name, and it tries to read in name. If name is still blank, while won't be satisfied, and it'll ask again, and it'll ask again, and it'll ask again until name is not blank. However, if you did pass in an argument, it'll actually skip the while loop and come down here to the else and do the assignment that we had before. Now, one thing that's important is we're currently trying to ask for a variable that doesn't exist yet. So what we need to do so that we don't get an error is put in name equals empty. So we're actually now creating the variable empty, and then we will use it later. But this allows our while loop to look at name. Otherwise, it'll give us an error and tell us that name doesn't exist. One thing I want to show is I actually have an error here. The while loop needs to be closed with done, but I'm going to leave that off for a second, and I am going to run it as is. Now, if you notice, it ended the script. That's where that set-e came in. So it's telling me, line 12, there's a syntax error, your unexpected token, else. Please get used to reading debug. It's very useful. Line 12, else. So it's telling me somewhere around here there's a problem. And the problem is the while loop is not closed. So I need to put in done. This closes out the while loop. So when you have loops and if statements, they open and close. So you open with while and you close with done. You open with if and you close with fi. The else is an intermediary statement. So this else is actually part of this if statement as a sub command. But you have to close it at the end, otherwise it won't work. Now if we run it, enter name, enter name, enter name, and just run the loop. Now, one other thing is we took out this chunk down here. So this is where it would actually tell us about name and exit and actually print the name. Now, we don't need any of this logic. I only copied it just to show you. We don't need this, and we don't need this, because we now have all of our checks up here, and we handle it. So now you can just say echo hello name. So now we have all this extra code here, which I will get rid of. Clean up the script. Do a little formatting. Put some spaces so it's a little more legible. All right, so now we have a complete script, which will ask you for your name. And if you don't give it one, it'll keep prompting you until it has one. Then it will print your name, and then it will ask you a question on how many times you want to run this loop, and you can have the loop there. Another thing, this is where error handling would come in, is technically if you run this script, enter your name, how many times you want to run the loop, and you put in an invalid character like J, it won't evaluate properly and it will actually just print out the statement. You can actually put in error handling to make sure it's a number and all of that out of the scope of this video. And that is your introduction to bash scripting. It's not really that bad. Some of the syntax is a little funky, but it can be so useful once you start learning how some of it works and you start implementing it, and you do it in little pieces. You start with a basic script. You don't have to start with advanced checking or anything like that. I have the if statements and the checking for the name, but if it's just for you and you know you're always going to enter the name, you don't technically need all of that. Now, it's nice to have, and it'll catch if you make a mistake, and it's good to put in, and it's good practices, but that all comes with time. You can start by just simply doing the basics, writing a string of commands, and going from there. So we'll do a quick little last example where you can do, you can literally just be like, yay, NeoVim, yay. Well, you need your -s, and, so you can install your packages, and then you can be like, copy my config to /config folder and stuff like that. So your script can be as simple as just a string of commands here. I went into the other stuff to show you where you can take it, where it can go, and how far you can expand it. But your script can also be literally this simple, just setting up a couple of basic things for you. I hope that was helpful. If you guys liked it, please like, comment, subscribe. Let me know what you thought of it. If something was unclear, let me know. I'll answer the questions in the comments. I am more than happy to do more videos on this as well, taking it further, going deeper into the bash scripting. Let me know what you guys think, what you want. I am reading all of the comments, and thank you to everyone who has already subscribed. You guys are great, and thank you.